So for the x components in this question, remember the k value is always it's got to be by itself. So I've removed it, and that's what this is. The k value is 1/2. If I have a k value, it's on the inside. We know the inside behaves in the opposite way. So I'm actually going to take the theta values, multiply them by 2, and then what? You guys subtract 60, right? Okay, again, if you're confused on where that 60 came from, it has to be when I factor out 30 divided by 1/2 when I common factor, which is 60. So those points become 2 times theta. This is going to be negative 60. 1. 2 times 90 is 180 minus 60. 120? All right. $270 times 2, 540 minus 60 should be 480. And 0, and then 2 times 360 is 720. Minus 60 should be 660, right? It's okay? One second. I just want to write that down. Okay. Gabe? Yeah.
So 180 times 2 is 360. Minus 60, wouldn't that make it 300?
Oh yeah, there's 300.
Oh, instead of 270?
Yeah.
Sorry. Yeah, pretty sure your intervals of increase should be the same too. Everybody know what I mean by that? So as we go across, like, those points have to be equally spaced from one another in terms of x. Eh? Are they all?
Well, the distance between them is 180.
What do you mean?
That's all you're talking about.
I'm just looking at, like, there'd be the x difference there, right?
Yeah.
Oh, you're right. Oh, we're right. We're good. Okay, just as a little check for yourself. I was getting thrown off by the negative 60. Okay, so those all have to increase by the same amount, right? In this case, it's 180 degrees. Okay, so that takes care of the theta portion of this. And then the y, so how is the y getting affected? This is pretty much going to be your final mapping statement here, if you will, right? You're going to get 3 times the y values minus 2. Right? And so 3 times 1 is 3 minus 2 should be 3 times 1, this should be 1, right? And then 3 times 0 minus 2 should be negative 2. Is anybody getting, like, thrown off at all? Like, I keep writing down these values over here because I'm looking at that point. So maybe that's pretty common. So just, I would say in this second column, maybe your first step would just be to rewrite those out so that you don't confuse yourself, and then do the work with the y's. Okay. So 3 times -1 is negative 3 minus another 2 is going to be negative 5. Does that sound right? And then 3 times 0 minus 2, that's back to negative 2. And then 3 times 1 minus 2 should be 1. So you have to get all the way down to negative 5 as our low point. And maybe we're going to count by ones. Okay. And what did we say? When did you scale this one at what? 120?
I scaled it up. Well, every 2 is 120.
Right, so 60 boxes, 60 intervals.
Yes.
So 120, 240, 360, and then 440.
Yeah.
Do you want to just read those out to me?
All right. 440, 600, 720, 840, 960, 1080, 1200,
Oh, 1080, and then
1200.
1200. Okay, is that all we need?
You need 1320 and 1440. But you don't like need all of the 1440. The last point's gonna be like
No.
1330. Or 1380.
Okay, the only tricky bit about doing this now is I think the original graph's going to be a little bit.
Weird.
There's going to be some guessing maybe on where some of these points are, but it's not that bad, right? So if I graph the original cosine, it's going to be right here. 0, 1, 90 would be where? Somewhere in here, right? Halfway. Well, I guess it's not really guessing. It's still pretty good, right? And then 180 would be where? Halfway between 120 and 240. Okay. Let's see how I do here. Okay, that's the graph of y equals cos theta. Okay, 2 cycles of it. And then I'm just going to plot those other points. So it looks like I have to go where? Because I moved the graph left. I'm going to have to count into the negative direction as well, right? So negative 120, then negative 240. Okay, and so I'm just going to go plot those points and then we're good, right? So negative 60 and 1 would be here. Does that seem right? And then 120 and negative 2. And 300 would be here, 300 and negative 5. And then I recognize the pattern now, right? Like I'm not really plotting the points, I'm recognizing the pattern. So like all I'm doing is I'm moving down 3 and then right 3. I've now reached the bottom, so now I'm gonna go right 3, up 3, right 3, up 3. You see what I'm doing? So I'm going down, right, up, right, up, right. I'm just recognizing the pattern off of the first 3 points, and then I can continue that because it's periodic. That saves me a little bit of grief and maybe putting a point in the wrong spot, right? Everyone see that? A much better way to do this, I think, with the mapping statements than trying to apply all of those transformations in the way that we have done it in the past, right? And that's just reinforcing what I was telling you before. Sometimes like it's very easy just to reflect a graph and then move it around on the grid, no problem. But other times the mapping statement is a more robust and powerful way to do this. Okay, so just knowing both, they're having multiple approaches is beneficial. Okay, so that's one cycle of this graph. Then I gotta go, I'm just gonna draw the second one now. And again, all I'm doing, I'm just recognizing the pattern. I'm not looking at the X values or the Y values. I'm just drawing the pattern in. Okay, so that would be the graph of y equals 3 cos 1/2 theta plus 30 minus 2. Okay, let's answer some questions about it. What was the first one on? Oh, the period. The period's what? Okay, not the easiest one to identify now, can I really, because it's been phase shifted. And your axis is kind of ugly. So having that equation at your disposal is kind of handy right here, right now. So period, the period we know to be 360 divided by the K value. And the K value we knew to be what?
1/2.
It's 1/2, right? So the period in this question should equal 720. Okay. And then that kind of deals with that horizontal work. That's kind of what we're interested in. And then we're interested in the amplitude and the max mins.
Yeah, max min, amplitude, and then I just put equation of axis.
Okay, so the maximum and the domain range. So the max is going to be 1. The min is going to be -5. And so the equation of axis is equal to the min, or the max plus the min divided by 2, which is 1 plus -5 divided by 2, which is -4 divided by 2. Okay, I'm gonna hit stop there for a second and just bring your attention, because again, our goal here is to be able to do the word problems. Where do I see -2 on my page or in the equation? On.
Vertical translation.
It's the translation up and down. So I've taken 0. My initial relative to the red graph would have been at the equation of the axis was 0. I took the equation of the axis, the whole thing, the whole graph, and moved it down 2. So guess where our equation of the axis went? Down 2. To y equals -2. Okay, these are all components that you can identify from the equation, for the most part. Right? You can tell the period from the K value using the equation. You can tell the amplitude from the compression a little bit. Actually, the amplitude in this question is a little bit different. Actually, no, it's not. You know what it is. It's not at all. You know the original amplitude is 1, and then you stretch or compress it by some amount. In this question, it was what?
It was well, it was still 3.
It's 3, right? So that, but the amplitude should be 3,
Yes.
right? Right. So the amplitude we can find by going the max minus the min divided by 2, right? 1 minus -5 divided by 2 is 3. Okay, but again, you know the original amplitude of these graphs, you know the vertical stretch. It's the A value. So if the original is 1 and we vertically stretch it by 3, then the amplitude has to be by 3. And the equation of the axis would have moved down 2, right? Is that it, Owen, or we got domain range?
Domain range.
So the domain, again, periodic graph. Theta can take on all values, all real values of theta. And the range, y is a part of the real numbers such that -5 has to be less than or equal to y, which has to be, greater than or equal to -5, and less than or equal to 1. Okay.